Hello, hello. And today I have the puzzle What Lies Beyond the Fog by ViKingPrime. This was recommended in a way that really tickled my fancy by GDC, whose puzzle I did, I think it was no, it was last Thursday. And I am very excited to try it. This is a fog of war puzzle, which basically means that all these gray cells are not just blank, they're fog. As I hopefully correctly place digits in the cells we can see, or potentially even in cells we can't see, that will remove the fog and reveal additional constraints. Now, the reason I've been hesitant to do one of these puzzles is that I tend to make a lot of mistakes. And if I put in a digit errantly that reveals fog and reveals constraints that I shouldn't know about yet, for me, even if I'm solving this on my own, I basically consider that like an invalid solve because I've kind of looked ahead into the future, and I make those mistakes a lot. So, if it's a hard puzzle, I might use up an hour on a video I can never use because I broke the fog puzzle. But I'm going to try it just based on the recommendation and hope it works out. So I'm going to try to go slowly and carefully and make sure I don't accidentally place a digit incorrectly. That's going to be especially a problem here because it's a liar puzzle, which we'll get into in a second. So the rules that you see on the screen are very abridged, even from the somewhat abridged version that ViKingPrime wrote out. And so I'm going to try to explain the rules as they come up. So the first rule in this puzzle is a global constraint called Schrödinger cells. And it's kind of a complicated rule set if you've never seen it before. So normal sudoku rules are that you need the numbers 1 to 9, every single digit, in every row, column, and 3x3 box, the marked boxes. So in Schrödinger puzzles, it's not the digits 1 to 9, but the digits 0 to 9. So it's an extra digit, but you still need to fit every digit into every row, column, and box. So there are 10 digits to place in 9 cells. So how do you do that? You do that by making one of the cells. So one cell in each row, column, and box is going to be a so-called Schrödinger cell, which contains 2 digits at once. And for the purposes of this puzzle, for all the other clue types, those 2 digits will both be valid, and you'll add the digits together to put a value in that cell. So for example, if this were a Schrödinger cell with a 4 and a 7 in it, then the value of this cell would be 11 for the purposes of that clue. And I'm going to mark all the Schrödinger cells I find as red, and I'll use green to indicate cells that cannot be Schrödinger cells. So that's that global constraint or global kind of additional rule. We have these V's. So V's mean that the values of the 2 adjacent cells, I'm going to try to be careful to say value instead of digits here, because if it's a Schrödinger cell, it could have 2 digits, and the value will be the sum again. So the values of the 2 cells across a V will have to sum to 5. These green lines are German whisper lines, which mean that adjacent cells along the German whisper need to have values that have a difference of at least 5. And what that's going to mean here is I can put 5 on German whisper lines. I'm sure I'm going to be tempted to make that mistake at some point. I can put 5s on a line, actually for 2 reasons here. One is that I have zeros, so I could put a 5 across from a 0. That would be okay. But also the Schrödinger cell could be as high as 17, which would be no problem pairing with a 5. So Schrödinger cells really mess with a lot of the German whispers shorthand that people have thought up. And then finally I have this white Kropki dot I can barely see. I guess I can see half of it. And adjacent digits across from a Kropki dot need to be consecutive. I'm sorry, not digits, values, right? So this could be, I'm going to be careful here. This could be a 4 rather, and this could be a 2-3 pair Schrödinger cell, and that would be valid. Let's make it a little different because the 3-4 also makes it confusing. This could be 7, and this could be 3-5. That would work. That'd be just fine. because this sums to 8, so 8 and 7 are consecutive. Okay. And there are other rules here. I will try to just explain them as I get to them, rather than try to explain them all now before we actually see the constraint. But that's all the clue types. There's one more global constraint, which is this 2 truths and a lie constraint, which says that for every clue type, so here I have 3 of the V's. So for each clue type, in this case V's, there are exactly 3 of that clue type. So I can see all 3 V's already in the puzzle. And those 3 clue types have 2 truthful clues, meaning they're valid clues. You treat them just as if they were a normal clue in a normal puzzle. But one of the clues is wrong. And not just you could ignore it. So in the GDC liar puzzle I did last week, if it was not in a wine cell, right, then you could just ignore the clue. Here, you can't just ignore the clue. It's actually actively wrong, right? So it can't just also coincidentally be true, right? So there are 3 clues. 2 of them are correct, and one of them is definitely incorrect. So it violates the constraint in some way. And I think that's all the explaining I should do before I get in. Again, as I see the new clue types, I'll try to remember to explain them as they come up. And the first thing I'm clearly drawn to are these V's, right? Because I have all 3 already. And so I know 2 of them are correct. And so 2 pairs, and further, this central cell, it's not central really anywhere except in the V. This cell here, row 4, column 5, is part of every single clue. So this cell here is very special. It is going to pair with 2 of these cells to sum to 5. Which should be impossible, right? It should be impossible, but the Schrödinger cells, I'm sure, will make that possible. So how is that going to be possible? Well, whatever I put here is going to be somewhere between 0 and 5, right? Because it can't be more than 5. Whatever I pair it with will then also be more than 5. Because there are no negative numbers. As weird as the Schrödinger cell constraint is, I still can't have negative numbers. And whatever I'm going to pair with, I'm going to pair with it twice, something that will sum to 5. And if I pair with it twice, what that is going to have to mean is that one of them is a Schrödinger cell, right? Because, if this were, let's say this were 3. I'm trying to be really careful not to accidentally place a digit here. I would need to pair it with 2 twice. It could be those 2, it could be those 2, it could be those 2. It doesn't matter which 2. I need to pair with it twice. And I can't just have 2 2s in the box. It doesn't work. So I'm going to need to have a 2 and something that sums to 2 in the box, which means this can't be 3, right? So this can't be more than 2 because there's no way to get a digit that's, so if this were, say, 3 or higher, then we have to pair with a plain 2 and then something that sums to 2. But I can't get 2 digits that sum to 2. Well, I guess I could have 0, 2, but that doesn't solve the problem of I still have a repeated 2 here. Right, so ignoring 0, because if I use 0, I get the same digit twice. That's not going to help me. So ignoring 0, I can't sum to 2 using 2 other digits. So this can't be 3 or higher. This has to be 2 or lower. But I think it has to be 0, right? So if this is 2, it's going to need 3s, 2 3s. So it's going to be a lone 3 and then a 1 2 pair. But the 1 2 pair can't actually work because I already have 2 in the center. So it can't be 2. 1 is the same problem. And it pairs with 4. But 4, the Schrödinger version of 4 is a 1 3 pair. But the 1's already taken. So this is just a 0. I'm fairly sure, but I'm going through that all in my head again to make sure it's real. Because once I place it, that either reveals fog or doesn't. I guess if it doesn't reveal fog, that I could still recover from that. The problem is if I do something wrong that later accidentally reveals fog that I shouldn't have been able to reveal, that's when I really feel like I just invalidated the puzzle design. Because otherwise, if I just put a 0 there and it doesn't turn out to be right, it's a bummer that I got the logic wrong. But that's no different than another Sudoku where I put a digit there that turns out to be incorrect. Let's try it. Okay. So I get a whole ring of Kropki dots here across from a 0 and no other clues down here. So let's look at the ring of Kropki dots. And actually I'm gonna put down here some green to indicate that these are not Schrödinger cells. One of these is just a 5 and the other one is a Schrödinger 5, which is either a 1-4 pair or a 2-3 pair. Okay, so let's think about these, because two of those black dots are right and 2 of those white dots are right. And I'm thinking, can this white dot be right? So can this be a 1? And that's the only way that would work. Like, could this be, I'm pencil marking it so that I don't reveal accident. And I'm not saying this is a 1. I'm asking, could this be a 1, right? If this is a 1, what does that mean? So for the white Kropki dots, that's okay. I could just put a 2 or a 0 actually in one of the others. That would give me 2 valids. It doesn't matter what I put in the other one. That's fine. What about the black Kropki dots? If that's a 1, yeah, that's not going to work, because if that's a 1, how do I have 2 valid? By the way, a black Kropki dot means that the digits across from the black Kropki dots need to have a ratio of 1 to 2, meaning one is going to be double the other. I don't know which order that goes, but one's going to have to be double the other. And that doesn't work with a 1, because a 1 could double to 2. And specifically, it doesn't work in the box, right? So it could, if the black Kropki dots were down here, that could work, because I could have 1, and well, it doesn't work with a given 0, but if I didn't know what this 0 was, I could have 2 here and here in those highlighted cells, and they don't see each other, so that could be okay. But with a 1 with all the black Kropki dots touching it facing somewhere else in the box, if I put 2 2s here, those will see each other, and I can't use a Schrödinger cell to get a 2 some other way. So this isn't a 1, which means this is not a valid Kropki dot. This is, though. This is a valid. These 2 Kropki dots going left to right are valid. So this is going to be like a 1 2 3, 2 3 4, 3 4 5, triple, something like that. And then, so what can I put? What can I put here? Because whatever I put here is going to need 2 valid Kropki dots. So can these both be valid black Kropki dots as well? And the answer is, I'll let you pause for a second if you can't come up with it. Right? The answer is no. Because if these are both valid black Kropki dots, then going along here, right, let's say I call this X. I can't, let's say, well, whatever. Let's just call this A, maybe, right? If this is A, then this is, well, I guess I don't know if it's going up or down, but if it's going down, just repeat the logic from the other side, it's the same. So I'm going to assume they're going up for a second. If this is A plus 1, and this is A plus 2, right? Or, again, it's going right to left, A plus 1, A plus 2. If these are also valid black Kropki dots, then A plus 1 also has to be 2 times A. And I do that twice in a row. And there's no number I can start with that's going to both double and half. Sorry, it's both going to double and add 1 twice in a row. Or I can do that once. The only way to add 1 and also double the number is to start with a 1. So in fact, well, do I know that? I'm not sure about that. But let me continue this train of thought. So I can't have 2 valid black Kropki dots along with the 2 valid white Kropki dots next to each other. So this black Kropki dot is going to be valid, along with one of these. And I know then, I know that one of these, either the left center or the right center ones, is both a valid white and black Kropki dot, which only works if it's a 1-2 pair. Right? It only works with a 1 and a 2. The only way to have x plus 1 equal x times 2 is x equals 1 for positive numbers. Or 0, for 0 or positive numbers. So one of these is a 1. This has to be then a 2. And it can't be a 0-2 Schrödinger cell, so it's just a plain 2. It's just a plain 2. Yes, it's just a plain 2. And I have 15 cell single cage 15 cells. So we'll talk about that in a second. But let's think about these black Kropki dots some more. So one of these is a 1. And since these white Kropki dots are both valid, the other one's a 3. So this is a 1, 2, 3 in some order. And this, therefore, is a 4. But it could be a Schrödinger 4. If it's a Schrödinger 4, it's either 0, 4, but it can't be 0. And it can't be a 1, 3 pair. So this is just a plain 4. Good. And one of the is 1 and one is 3. And the 3 can't be Schrödinger either. So neither of these are Schrödinger cells either. Actually, let's just think about the 15 cages, because that's going to fix all this. So, or at least the Schrödingerness of that. So I have 2 cage clues now. And a cage clue means that digits in a cage don't repeat, and they sum to the value given. So in this case, they sum to 15. Now, I could just disregard both those clues, but they can't both be wrong, because there are only 3 clues. Only 1 is a liar, and 2 are correct. So how do I get a 15 sum single cell cage? It's got to be a Schrödinger cell. And so I have to have a Schrödinger cell cage that is either 6, 9 or 7, 8. And since one of these is a Schrödinger cell, nothing else in the box can be. That's what I meant before when I said it fixes. Like, I didn't really have to think too hard about whether those are Schrödinger cells, because one of those has to be. And then one of there can't be another Schrödinger cell in the row either. So one of these is either a 6, 9 or 7, 8 pair, and the other one won't be a Schrödinger cell, so it clearly just will violate the cage rule. Now, can this be 6? So what is this cell? Because this actually sees all the low digits, right? So this sees 0, 1, and 3, and 2, and 4. So this is at least 5. And these are not, and these cells see almost all the low digits except for 0. So how is this? Because, so these orange lines are Dutch whispers. Dutch whispers are just like German whispers, except instead of having a difference of at least 5, they need a difference of at least 4. So they're not quite as restrictive, but they're still pretty restrictive when all the low digits are gone. So how is this going to work? What digit can I put here that can have 2 other digits? Because 1, 2, 3, and 4 are taken. So the lowest these outside cells could be is 0 and 5. And even if it's 0 and 5, this has to be 9. That's the only way for this to be high enough to make that work. Because if this is 8, I'm going to have to put 5 or higher next to it. It's not going to work. This has to be 9. These have to be 0, 5. And since the 9 is gone, one of these is a 7, 8 pair, and the other one's a 6. Yeah, that seems right. One of these is a 7, 8 pair, and one of them is a 6. Now, how do I continue from there? Actually, so these, I didn't notice that before. These Dutch whispers, both lines continue. Sorry, I should have clarified before. Just like down here, or maybe I thought this in my head and didn't say it out loud. One of these lines has to be correct, right? One of these lines has to be correct because I have 2 lines here, and only one of them can be false. So one of these lines has to be correct. And so on the range where we have 2 lines showing, wait, actually, could this be, hold on. Now I'm worried that this could be just one long false Dutch whisper line or something. Okay, the only thing I did here was place this 9 from that, and that didn't reveal any flags. So if that turns out to be, let me think about that for a second. Could this just be one long Dutch whisper line that loops on itself and is wrong? Actually, I think there's something in my rules that are not in your abridged rules. Yeah, so sorry. So I'm reading the real rules. And there's an extra rule here that I didn't put in the abridgment, which I perhaps should have now, which is that disconnected lines within the same cell indicate 2 separate lines. Yeah, so these are not, in fact, this can't be one line that loops in on itself. This is 2 separate lines, which means one of them is correct. Same thing down here. So this is, at least on these 3 cells, and because both lines continue on these 5 cells, that is a valid Dutch whisper. And so one of these is a 5 on a valid Dutch whisper that can't pair with 0 or 9. So it's going to have to go with a Schrödinger cell. So one of these is going to have to be a Schrödinger cell. So these won't be. Right, so wherever the 5 is, because the other one is 0, I can't have a 0 value. Oh, but it could be 1. No, yeah, sorry, that's wrong. That could be 1. I could have, because I'm not in the box anymore. I could have 5, 1. Yeah, never mind. So how do I continue on? Because I can't, even though I know this is a Dutch whisper that is valid across those 5 cells because both lines go through. The 0 is easy, right? The 0 can pair with just about anything. The 5 will have to pair with a 1, a regular 1. But that's fine. Right, so I know these are from 1, and I don't even know that I can't have 2 or 3 there because this could be a Schrödinger cell. So on the 0, I could have a Schrödinger cell, 2-3 pair, or 1-3 pair. So what do I do? I'm not sure. I'm not sure what to do next. 9420. Do I have to think about what all these did? Maybe I have to think about whether these can both be 5. Maybe that's the right way. Because I noticed that if this is one of the valid V's, that's just a plain 5, which would reveal some fog down here. And the reason it can't be a Schrödinger 5 is 2 3s taken and 1 4 are taken by these digits that see this cell. So if this is a real 5, if this is on a valid V, it's just a 5. It can't be the Schrödinger 5, the Schrödinger cell that sums to 5. So is there a reason those can't both be a V? Sorry, both be a valid V with a 5 on it. So what if that were true? So if this were 5 and say a 2-3 pair, what would happen as we continued on? Well, one of them could just be broken, right? One of them can just be broken. So I only have to think about, is there a reason that a 5 would have to continue to be broken? So what would a 5 do on a German whisper? It would go, it can't go to 0 because 0 is taken. But it could go to like 10 with a Schrödinger cell. Oh, but it can't because if these are both V's, one of those would be the Schrödinger cell. This would not be. Yeah, okay, so that is the way. One of these, it can't be the case that both of these are the 5s, the V clues, because suppose that were true, and this is broken, right? This becomes a green non-Schrödinger cell because one of these is a 5, and one of these is a Schrödinger cell that adds to 5. And now both of these German whisper clues continue, but one of them has to continue correctly. And whichever one of them continues correctly is continuing into a non-Schrödinger cell, because one of these would be a Schrödinger cell in this hypothetical. So let's say it's this one just for illustrative purposes. This would continue on to here and have to be a non-Schrödinger clue on a valid German whisper with a 5, but 0 is taken. And that just doesn't work. So this is a real 5. This is a real 5 clue. And it can't be the Schrödinger cell because it can't be a 2-3 pair. It can't be a 1-4 pair. So this is just a non-Schrödinger 5 on a 6 cage. So how does the 6 cage? So yeah, that's clearly what I was supposed to do. And where is the 6? And it's 3 cells long without a 0. No, this could be 0 though. So this could be a 0 with, well, not a 2 pair actually because of this. So what can this be? These can obviously be 1, 2, or 3. Like what I'm thinking about what digits these could be. They can't be 5. Could they be 4? So this can't be 2 or 4. Can this be 4? It clearly can't be 6 because 6 and 1 even is going to be 7. So can this be 4? So if this is 4, I could have this couldn't be 3 then because that would sum to 7. So if this were 4, that would have to be 1. That would sum to 5. And then I would need, that doesn't work because I need another 1 somewhere else. Somewhere else in the cage. If this were 4, 1, I would need another 1 to get up to 6. So that doesn't work either. So that's not 4. So this is a 1, 2, 3. Or I guess it could be 0, 1, 2, 3. It's essentially a 1, 2, 3 cage. How do I know what goes where? Oh, it's this. Right, because one of these is now a Schrödinger 5. Right, so these are not Schrödinger cells. One of these is a Schrödinger 5, but now I know which one it is. Right, and by that I mean I know how I'm summing to 5 now. Right, so how am I summing to 5? It's not 2, 3. Because if it were 2, 3 summing to 5 here, these cells would both have to be 1, and that now breaks. So that's not a 5 anymore. So one of these is a 1, 4 Schrödinger cell, which means there's no 1 down here either anymore. So this is a 3, okay, and that's a 2. That's a 2. And it is a 4 cell, so this is a 0, 1 pair. This is a 0, 1 pair on an X, which is valid because this one's not. So X clues sum to 10. This doesn't sum to 10, so this is my liar X, which means I have 2 real X's somewhere in the puzzle. I have 2 real X's in the puzzle. So this is actually 9 or 10, but I also have 2 circle clues. I'm very confused right now because I feel like both of those circles have to be wrong. And I'll explain why in a second. Well, I guess I'll just talk through my confusion here. So I did another ViKingPrime puzzle actually, which was a liar puzzle with circles in it. And so what is a circle cell? Circle cells, the clue in a circle cell, if it's a valid clue, it means that any digit that appears in the circle indicates how many times that digit appears in circles throughout the puzzle. And I know that there are exactly 3 circles in the puzzle because of the 2 truths and a lie constraint, or not really constraint, the condition on constraints. And now the other puzzle I did with these didn't have Schrödinger cells. So maybe that's just messing me up. But in the non-Schrödinger cell version of this puzzle, where I have 2 truthful circles and 1 lie circle, the only way to make that work, I concluded, is to have 2 of the valid circle clues be the number 2, and the other be almost anything else except a 1. Because if it was a 1, that would also be a valid clue, and then all 3 would be valid. So because you can't have 3 3s in circles. Again, we're going to ignore S cells or Schrödinger cells for a second, because that's going to complicate my thought process. So if there were no Schrödinger cells, you can't have 3 3s in 3 circles, because then they're all valid, and that violates the 2 truths and a lie. This is a little weird. I actually just recognized the pun in What Lies Beyond the Fog is the title. Like which lies are beyond the fog, lies being the pun there. That's embarrassing. Anyway, I just got that. So you can't have 3 in a non-Schrödinger cell circle two truths and a lie puzzle, because then all the circles, to have a valid 3, all 3s would have circles, but then all 3 circles would be valid. That doesn't work. You can't have a valid 1 in a circle, because if there's a valid 1 in a circle, then if it's valid, that's the only circle with a 1 in it. And now I have 2 circles left over where one's valid and one's not. How do you make that work? Because you can't put a 1 in either circle, because that would make the first one invalid. The only way to make the circles valid at that point then is to put a 2 in, because you can't put 3 in. You can't put more than 3, right? Anything more than 3, there aren't even that many circles in the puzzle, so that would clearly be invalid. So the only way to make that work is to put 2s in. The 2s, if they're both 2s, either they're both 2s, in which case they're both valid, and then I have 3 valid circles. Or there aren't 2 2s, in which case both circles are invalid, and then I have 2 invalid circles. But here, which am I more confident about being in? Because I feel like both of these are invalid. I mean, I don't really think that. I'm sure the puzzle is correct. And I just need to think more carefully about how the Schrödinger cells changes the logic. How Schrödinger cells change the logic. So it's still got to be true that I can't have a cell. I could have a 3 though now. But I can't have anything higher than 3, right? Because if I have something higher than 3, then that's just clearly invalid. And if it has a 4 or more, there aren't 4 circles, that clearly is invalid. But this cell, by virtue of being on a valid x with something that values that is either a 0 or 1, so this sum is at least 9. Even if it's a Schrödinger cell, to get a sum of 9, I have to have something that's at least 5. And in fact, it couldn't even be a 4 or 5 pair. I need something that's at least 6 in this cell to get to 9. And so this just cannot be a valid circle clue. This just cannot be a valid circle clue, which means this is. But it can't be, so it clearly isn't 0, right? It can't be 0. Because if there were a 0 in a valid circle clue, that would tell me that would tell me that there are no zeros in circles, which would then be false. So if this circle is valid, it's 1. I'm very confident that this is an invalid circle because it has to have a digit higher than 3. So this is clearly invalid, which means this is valid, which means it's a 1. But how is that going to work? I just want to make sure I can think of a way that it could possibly work before I put a 1 in there. So if the 1 is there, that means it's a valid 1, which means there are no other 1s in circles. And somewhere in this puzzle, I'm just going to put it like here for a second. So I'm putting a 0 there as if it's a circle. Somewhere in this puzzle, there's a third circle, which will also be valid. How is it going to be valid? It can't have a 1 in it. It can't have a 0 in it. It can't have a 3 in it because this circle doesn't have 3. It's going to have a 2 in it. Oh, okay. Yeah, so the other circle is going to have a 2 in it and only a 2 in it. And this circle will also have a 2 in it, but will have something else that will break it. Yeah, that's the way it works, actually. So this is a 1. This is a 0. It gives me some German whispers. This is my Schrödinger cell. Now, you could say, well, it's just a 9. And that would be fine, except my third circle somewhere in the puzzle would then be broken because whatever I put there would be invalid. It would either invalidate this 1 or itself would be an invalid clue. And this is going to be a 2-7 pair. Right? This is going to be a 2-7 pair. To make that third circle somewhere in the puzzle just a valid 2 and have it still work. Because it's the 7 that's breaking this circle, not the 2. Okay. Now, does that tell me which way this goes? Hold on. So we said before, so one of these is a Schrödinger 5, And no matter where it goes, it's going to break. No, these are both non-Schrödinger cells, so that's not going to help me determine. So one of these is broken. The other one is a high digit with a low digit. But this, I mean, this could be 4. Well, it could be 4-9 because one of these is a 4. But this could be 3-8. That'll be fine. So what's the problem? I have this German whisper down here. Is that doing something? So this cell is not Schrödinger. And it's not 0 or 1. I almost said it can't be 6, but it could be because this could be 0, 1. Because with a puzzle without Schrödinger cells, you can't have a 6 in the middle. But here you can. This can't be, no, it could be 4 because one of these could be a Schrödinger cell. The sum's really high. So what do I do here? I've got a new German whisper line. What is it telling me? I don't see what it's telling me. Because, yeah, I mean, I just think of lots of valid ways. I mean, it can, and this might even not, no, one of these is broken. Whichever, but this could be connected. Oh, geez. This doesn't tell me anything because this could be broken, right? This could be a valid German whisper line that ends here. The bottom one could end here and be valid. This one could loop all the way around up here and be broken with the Schrödinger cell here. So this actually isn't telling me anything because I don't even know if it's a real German whisper line. So this is not where I'm supposed to look. So where am I supposed to look? This is where I revealed the flag. This is where I should be looking. So okay, I'm trying to think through what we just did. So we went down here, and then I just revealed, but this didn't reveal anything because it's a Schrödinger cell. I didn't actually place a digit, according to sudoku pad. So, but I did just put that there. So does that help me? Does that help me in here somehow? I have a 2, 2. One of these is a 2. I have 7. One of these is a 7. Do I get some interplay? Because one of these is a 7 too. So I got a 7 here. Is there some interplay with the Schrödinger cells and the 7s? So it's hard to think through in my head. If this is a Schrödinger cell, this is the 7, 8. And then the 7's going to go here. No, the 7's going to go here because of this 7. So if this is a Schrödinger cell, I get a 7 here. No, but if this is a Schrödinger cell, then it's a 7, 8 pair and the 6 is here. The 7, 8 pair makes a 7 not here, not here. And so the 7 should have to go here. But if this is the Schrödinger cell, this is not. So this is the Schrödinger cell, but the Schrödinger cell is a 1, 4 pair. So it doesn't work. So that is a 6 plane. And I get another valid X. Hold on. This is not a 6. This is my Schrödinger cell. So these are not. So this is. These are not. This is my 1, 4 pair. This is not. This is just whatever. And this is now this is my invalid. But this could still wrap around. Oh my goodness. This could still wrap around here. And I just revealed some stuff up here actually. So I think I'm going to think about that. But so the top German whisper here that goes to the left is invalid because I can't. 5, this is not Schrödinger, so it can't be 10 or more, and it can't be 0. So this is invalid. This one's valid. So now this is a valid, and it's got to be, or does that have to be a low digit? This is at least 6. In fact, it's 6 or 9. If this is 6, 0 is taken, so that's 1. So actually, this is a 9. Is that right? This is a 9? Yeah, that's a 9. Whoops. When the fog didn't reveal, I had a heart attack, but then I saw it was blue. I just was in the wrong spot. That's a 9. Okay. Oh, that's neat. I'll think about that in a second. So that's a 9. This is a low digit, but not 0, 1, or 2. So this is 3 or 4, but not 4 actually because of this. So that's a 3. And this continues on. That must be 8. And now that's a valid Dutch whisper. And then one of these is going to be valid, one of these is going to be invalid. Okay. Now I have 2 ways. Let's think about this because I've got relatively less distance to look. This one could be all kinds of weird twisties. So here, I definitely have a valid Dutch whisper here. And if that's a 5, that would make this 1 because the 0 will be taken. If it's 0, this could be just about anything. It could be 4 plus. And that's a valid X clue because this is invalid. So this is a valid X clue. What is this possibly? This is 1, if that's 5. If it's, and then this would be 9. If this is, this could be this could be a Schrödinger cell, but not a Schrödinger 1, because it's going to be 1, 0. But this could also be high, right? This could also be, it could have a value of, I'm going to pencil this in even though it's values, with the understanding that it could be a Schrödinger cell summing to that. It could be, I guess as little as 4. Well, no, 4 would pair with 6, which doesn't work. 5, it could be a Schrödinger 5 paired with 5. That would be okay. 6 would pair with 4. 7 would pair with 3 is okay. 8 would pair with 2 is okay. 9 would pair with 1 is okay. Actually 10, there's 0 there to be 10, would pair with 0, which is okay. That is not very helpful. Okay, that's not helpful. So maybe it is over here. So this, at the very least, this goes into this cell as well, and these aren't Schrödinger cells. So this is a valid Dutch whisper. Okay, so this can't be the 5, because if this is the 5, it would have to pair with 1, which is taken. So this is actually the 0, and this is the 5. And now, because it's a double, this is valid the whole way through. So this is a high digit, so it's at least 4. 4, 5, no, not 5, 6, 8, 4, 6, 8. 4 would pair with 9, which is okay. 0 is taken. 6 would pair with, because these are not Schrödinger, so I don't have to worry about sums. 6 would pair with something low. No, it can't be 6, because 6 would have to pair with 1, 2, or 0, which are all taken. 8 could pair with 4, which take, so that's a 4. And that's a 9. This is another low digit, but not 0, 1, 2, 3, or 4, so that's 5. Now I'm nervous. Am I correctly placing digits? Because the fog, there's no fog to reveal right there. And so now I'm worried. Oh my God, I'm almost 40 minutes into this puzzle. I feel like I've made some pretty good progress, actually. I kind of knew going into there this might be a bear that would take a while, so I gave myself plenty of time. So this is a valid German whisper from a 5. It could just be a 0. Not a Dutch whisper. It could be a 0. It can't be 1 because of this. But this also could just be a really large Schrödinger cell. Right? I mean, it could be as high as 13 with a Schrödinger cell. Okay, so what are these two digits? Because this column's almost done. I need no, I have a 2. I need a 6 and an 8. And the problem is I still don't, I know that this one going left is invalid, but this could wrap all the way around to here. So I don't know that this is valid. Right, if I knew this were valid, I could put an 8 here. 8, 6. And then this 8 would have to go with 1 or 3 over here and 1, 2, or 3 over here. I don't see why this couldn't wrap around to that invalid German whisper. Well, actually, here, much easier. I can place a 7 here. Oh, and that gives me that circle, which we decided before is a valid 2. Now do I know that's valid? Hold on. How do I, is there a way to draw this? I still feel like this could loop around and down like this, and this could go up or stop and be valid. That's not 2. What are these digits? These are 6 and 8, but I know which way. That's 8. That's, there we go. That stops. So now we see that this stops. So this is a German whisper. That's valid. That makes this an 8. This is 1 or 3. This could be a Schrödinger 1-2, I guess. But it's definitely, the digits here are from 1, 2, and 3. This could be a Schrödinger 1-2 still. But it is not, it's not high, and it ends here. Whatever I put here is going to invalidate this. What's left? Okay, so this is a high. Hold on, what's left here? Let's go to the 7 because I know all the digits. It's 1, 6, 7, 8. One of them being 8. I can still have a 1 here because this could be a 1-8 pair something to 9 with a 3. That would be okay. Oh, but this is not a 1 then because the 1 has to be here. So that is a 3. Which doesn't, well, it tells me up here actually. That tells me which way this goes, which I guess tells me, I already knew those were all valid. But it tells me which is the valid black Kropki dot. Not that it matters at this point. So what are these digits? These are 4 and 5. And so these are 0, 2, and 9. This one's 9. So this sums to at least 8. But I could do that, 6, 7, 6, 8, 7, 8, 1, 8, 1, 7 even. So that's a 6, I guess. This is also high, but again, this could be a Schrödinger cell too. This could be a Schrödinger cell. Yeah. Oh, this is not 3 anymore. The digit 3. It could be a sum to 3 Schrödinger cell. Let's see. 3, 3. 3 is over here. 7 is up here. Which leaves 2 possible. What are the 2 possibilities here? 5 and 6. The other one's over here somewhere. What do I do next? 1, 2, 0, 2. This is high, but could be Schrödinger high. This will then be low, or Schrödinger doesn't help you. Well, no, this could be Schrödinger really high. Like this could be 17, and then we could put a 7 here. 1. So that, I actually don't even know beyond here that they continue that high-low exchange. What's next? I'm not sure. It's funny, I've definitely been baffled by this puzzle here, but I didn't feel like I was stuck, or I feel like I had things to think about. Maybe it's this. Maybe I can do something with this now. What did we say before? This has to be, well, this is the 5 now. So this could be low. Well, it's constrained a little bit by this X clue, which is valid. So this is either a 1, just a bare 1, non-Schrödinger, which would pair with an, oh, but it can't because of this 9. So this now is a Schrödinger cell. And these aren't. And it sums to 9 or 10, and that's 0 or 1. And because this is not a Schrödinger cell, now we know it's high. It could be a 5, though, because I got 0, 5, and a Schrödinger cell that sums to a high digit. So it could still be a 5, but it's not 8. And this sums to either 9 or 10. Without 2, 4, or 5, or 9. So if it sums, let's say this is 0 and it sums to 10, what would it have to be? It would have to be 1, 3, 7, 9. So 1, 9, no, it'd have to be 3, 7. Because 2, 8's taken, 1, 9 is taken, 4, 6 is taken. So if this is a 0, that's a 3, 7 pair. And if this is a 1, 0, 9 is obviously taken. If this is a 1, 1, 8 will be taken. 2, 7 will be taken. 3, 6 will be available. And 4, 5 will be taken. So actually 3 is here either way, which is kind of funny. So this is a Schrödinger cell. These aren't. These aren't. This is a Schrödinger cell with a 3 on it. And these 3 digits sum to 10. 3 and either 0, 7 or 1, 6. So that's not a 3. Whoops. But it's still green. Now one of these is Schrödinger for sure. I don't know which one. But I know there aren't that many low digits left. But there are a lot of low. So 1, 2, and 3. So 3 goes in this row. 1 and 2 are also up here. So 1, 2, and 3, at least 2 of them have to go on this Dutch whisper. And they can't be adjacent to each other. Yeah, 1, 2, and 3. 1, 2, there are 3 digits. 3 digits in 4 spaces. There's only 1 that's missing. So there can be at most 1 gap on this Dutch whisper that doesn't have a 1, 2, or 3 on it, which will have to be here. So this has to be a high digit. So it's got to be at least 5. But 5 is taken. So it's 6, 7, or 8. That's going to pair with 1, 2, and 3. And this will have to be the other one. So here I have a 1, 2, 3 triple now. So 0 is going to go down here. 0 could be here by itself. Let me do it this way, actually. And then 0 is here somewhere. 0 could be by itself here, I guess, with 6, 7, and 8 here. 0 could be paired, like this could be a 1 with 6, 7, and 8, a Schrödinger 6, 7. Oh no, but then this would be a non-Schrödinger 6, 7, or 8, which doesn't work. Hold on, can this be, what can this, how does this work? Somewhere here there's a Schrödinger cell. If 0 is in the Schrödinger cell, if 0 is in the Schrödinger cell, then I can basically ignore it. And then what I'm left with is 2 digits, 6, 7, and 8, that both go here. One of them will be adjacent to the 5 on a valid Dutch whisper line, which will break. So 0 is not in the Schrödinger cell. 0 is plain. And that means 0 can't be here, because then I'd have a plain 0 next to this, and that won't work. So this is a plain 0 in a non-Schrödinger cell. This is a Schrödinger cell with 6, 7, or 8 in it, which makes this a 5, and these not a 5. That's wild. I mean, I gotta say, when this was revealed, so far my favorite part of the puzzle was the reveal of this whole section. And I think between that and everything else in this puzzle, ViKingPrime has earned the king in his name. But I don't, yeah, it's wild how unexpected this has been. But enough gushing. Let's think about. So there's a 0 here. Let's do some sudoku. Oh no. I'm gonna keep going. It did reveal that there's nothing there, but I'm okay with that. Sorry. 0, a 0 here. 6 is here, but I know it's here. Okay, so I was about to reveal that in a second. I don't feel too bad about that. 0 is here. What do I need still? 4 and 9. I don't know anything about those. Yeah. Well, here, but now I have one. This cannot be a Schrödinger cell anymore, and these can't be Schrödinger cells because of this one. Because then I'd have too many. So this is a 1, 2, 3 triple now. Actually, this is just a 3. And that's not. This is now a 1, 2 pair, 3. One of these is my Schrödinger cells, and the digits I have left to place here are 4, 5, 7, and 9. One of these gets 2 digits, which is why I have kind of too much here. This one's not 9, I guess. This doesn't have to be a Schrödinger cell. Still, what's here? Oh, I don't really know because I'm gonna have a 4-9 kind of overlap, and what I definitely have is so there's gonna be one number that I know for sure is here, and that number is 3. Yeah, 3's got to be here, not in the middle. 6, 7. So now I have a 3, 6, 7 triple here. So this is not 6 or 7. Can this really be 5? If that's 5, that's 0. This is a Schrödinger cell with a big sum. This is low. No, it could be a Schrödinger cell with a huge sum, and that could still be high. I keep doing that mistake. Oh, but 5 has to be on this line. 5 has to be on this line, right? So this has to loop up like this. And 5 has to be on it. So this can't be 5. So one of these is a 5. So either this is 5, we get a Schrödinger cell here, and this can go however. Or this is not a 5, so it's 9. This is a 5. Will that work? If this is a 5, I could still put 0 here. Because only one of these can be a Schrödinger cell. I can't put 0 up here. Is this a Schrödinger? Oh my goodness. This is my Schrödinger cell either way. Because one of these is a 5. Whichever one is a 5. means that, wait, no, that's not right. I misspoke. I misthought, which led to misspeaking. If this is 5, this is 0, this is my Schrödinger cell. If this is 5, this one can't be 0. So this is 0, and this is my Schrödinger cell. So one of these is my Schrödinger cell, so these are not, at least. I don't know how much that helps me. But one of these is a Schrödinger cell that's larger than, that's 10 or bigger. Not sure. What's on here? I guess there's still a lot of choices because there's 3 digits here that it could be. But I know there's an 8 here at least. Yeah, I'm just a little stuck here. I know that this Dutch whisper has to be invalid, but I don't know if it's invalid right here, right? This Dutch whisper could continue on and be invalid somewhere else. So what's left here? A 1 or 2, and then whatever's missing from the 1, 2, and whatever's missing from 6, 7, 8 is what's here. Here I have less. Whatever's missing from 0, 1, and 2, and 5. And 5 here somewhere. And then it would be so sad to get stuck here after almost an hour. Hold on, can this be 2? If this is 2, this is 9, this is 5, this is the Schrödinger cell, this is the Schrödinger cell, and that could be huge. If this is 5, this is 0, this is my Schrödinger cell, this is 8. Oh, 8's gone. 8's taken. Wow, sorry. That's been sitting there. So if I'm being totally honest, when I don't do these live, I have the conflict checker on. Excuse me. So because of that, I think I'm out of practice scanning for those really simple deductions. So maybe I'll, in my spare time, go back to having that off. Anyway, so now that's my Schrödinger cell. That's not. This is. And since this is no longer a Schrödinger cell, this can't be a 5. So this is my 9. This is my 5. This is at least 8, which means it has to have a 7 in it for sure. So the 7's not here. This is fine both ways. This is my 0 now. That's 7, that's 2, that's 0. That's now 1. These are a 1, 8 pair. There's only 1 digit left. What is it? It's a 4. These are no, not 4. That's a 4. I just caught myself going too fast, but there's no fog over here, I guess, so it's okay if I mess up. There's a 2 left here, but I know from this 2 how that goes. My 3 now will be here. This is a large digit. This could also be large, though. There's no reason this couldn't be. This could be as high as 15, and this could be 6. Actually, 6 goes here somewhere. 6, yeah. 6 goes here somewhere. If this is 6, what do I put here? This would need to total at least 11. And if that were true, what do I have left? 6 and 9 are gone. I have 7 and 8 as high digits. So I'd have 7, 4, 5. Oh no, it can't be 7, 4 because then these would both be 5. 8, 3. No, 3 is gone. 2, 9's gone. If this is, yeah, so it doesn't work. So this can't be 6. So the 6 is in here. The other digit then needs to be at least 4. So 4, not 6 again, 7 or 8. I don't think that's actually that helpful. 4, 5, 6, 7, 1, 8. I know there's at least a 6, so that's not. Let me just double check my thought. If this is 6, this has to be at least 11 by the German whisper. Because it has to be at least 10. Like, I can't go low here. I mean, 0's gone. So I couldn't have a Schrödinger cell less than or equal to 1 anyway. So this is 6. That was at least 11. Oh, but sorry. Let me back up. Luckily I didn't reveal anything. I did that assuming it had to be exactly 11. It could be more than 11, right? So I could have 6, say 8, 4, 1, 5, 7. Yeah, that's okay. So sorry. Luckily I didn't write a 6 in. Yeah, no, that's not correct. Not that it was that. I mean, I got rid of the 6, but I don't know. That wasn't doing too much. So what should I be doing? And I should have another known digit here. There's definitely a 1 here. Actually, I think I had that before. Or I mean, I should have known it before, but didn't. This is whatever's missing from this 0, 1, 2. That's not 0. The other, so 0, 1, 2, I guess, there's 1 missing digit from 6, 7, 8 here. I also need 4 and 9. Yeah, I don't know what to do. I should probably look for things like this where there's just an 8 pointing at things. And I have this 3, 6, 7 triple. Maybe it's this column. 0, 1, 4, 5, 8. 1, 4, 8 is here. It's almost. Oh, hold on. Let me fix these Schrödinger cells at least. So this is now a Schrödinger cell that definitely has a 9. And 1 of 5 or 7. If it's 5, that's 4. I get a 1, 8 pair. That's 3, 7. If it's 7, I get nothing. Well, I get that. Well, if it's 7, then that's 5. So one of these is a 5. And that 5 will pair with a 4. But if it's here, that's 6. 1, 8 would have to go here. Then I would need 6, 8 here. And that would be 1. If it's here, we get 5, 4, a 1, 8 pair, 3, 7. Wait, no, I did that wrong. If this is 5, that's 7. So 7 is going to have to go up here. I get 5, 4. I have 6. I have 1, 6, 7, 8 in those 4 cells. Yeah, the way my brain fills in gaps really doesn't work well with Schrödinger cells. Because I work backwards from what's left. And I have to remember that there's 1 more digit left than I think there is all the time. So if it's 5, 4, this is 1 or 8. I get another 1 or 8 in here. with 7 and 6. Well, how's that going to work with, how high can, if I have a 1 here, let's say this is 1/8 even, which is the highest it could be with a 1. What do I put here? Well, this can't be 1/8 because of this, actually. What if it's 1/7? That's only 8. The largest this could be, and then 0, 1, 2, 3. So 1 is not here. 1 is not in this cell, which seems small, but I think 1 is not here. So 1 is in one of these 2 cells. What if 1's here? How do I make this work? If this is 1, we get 8, 1, 4. Oops, 4. And then what are these? This is going to be really big, but not with an 8. What's 1, 8, 1, 4, 5, 4. So if it's 1, we get 1, 8, 4. Oh no, that's the way it's probably going to work. What if this is 1? If this is 1, we get 8. Yeah, then I don't get as much in the column, in the rows. If this is 1, then I definitely have 8 over here. If this is 8, this could still be 13. Yes, I have 8, 6, 7, 4, 5. Just barely works. 8, 6, 7 would leave 1, 4, 3 here. I think that's okay. Oh, I don't see why it's not okay, at least. I feel like it's in this column. If this is 0, 7, we get 6 here. There just isn't enough to go on anywhere else. Which this is only 4. This could only be 4 or 8 because 3, 6, 7 are gone here. That is starting to almost look helpful. This is now 0, 1. This is 0, 0, 1. That's it. I should have filled that in. Because if I had just done this earlier, that would have been... for once in my life, I'm not marking the puzzle up enough. 0 and 1 are here, so that's not 0. This is not 1. This is a 4, 8 pair. Maybe less of a breakthrough than I thought. Well, that's got to be... This is 0, 8 pair. 3, 6, 7, 0, 1. 4, 8 pair. That makes us a 5. There we go. That's a 5. These are not a 5. That didn't help. That didn't finish the puzzle. I mean, it didn't do anything. How did that not do anything? 5s. Okay, now Sudoku. I've got a 5. I probably had this for a bit. I've got this 5, which will reveal the... Okay. That is what I needed to do. I have a 5 there by Sudoku. Now I know that this Dutch whisper is broken. So this is either 9 or 10. So this can't be more than 4 away from 9 or 10. So it can't be a real low digit. And it can't be 5. And conveniently, 5 is a digit that would make this ambiguous. Wait, no. 5 would make this valid either way, actually. So this could be 6 if it's 9. No, but if that's 6, that makes this a 7, which makes it 10. So this can't be 6 even. So this is 7 or 8. And now I have 3, 6, 7, 8, which makes this a 1, 2 pair here. This is 0, 1, 2 triple now. Well, no, I already knew that. So what's here? Something from 6, 7, 8? No, I'm just as far away as ever. 7, 8, 8, 9, 3, 3. What am I missing? What am I missing in this puzzle? One of these is 0. Let's see. Let's try more Sudoku. I just highlighted 5s, and that got me that 5. 5s are here and here. Okay, let's go with 0s. I'm not used to doing 0s. Yeah, no, I kind of did that in my head earlier. 1s. Oh, I have a lot of 1s left. Well, this is a 1. These. Yeah, any of those. Yeah, a lot of 1s left. Oh, 1, 2, there we go. It was Sudoku the whole time. Zero, 9, 6. What else has that done? That's not 2. That must be 2. That gives us 1, 2 here. 2. Are my 2s done? Yeah, 2s are now done. 3s are getting there, but not quite. 4s. Oh no, did I break it? No, one of these is short. Okay. I forgot. I'm telling you, the way my brain works on Schrödinger cells is not, it's not right. Oh, that's not a Schrödinger cell. That is between 4, 8, and 9. I've got 2 of the digits there. So this whole time I've been missing the fact that a 4 had to be here. So I didn't actually have an exhaustive possibility set, but I don't think I did anything that required that few digits here. So I don't think I did anything. I mean, I'll go back and watch the video again when I'm done to make sure, but I don't think I did anything that would make any of the deductions I made earlier invalid. So I'm going to keep going, even though I forgot that there was a 4 here. Okay, what if this is 4, 8? This is 0, 9. It doesn't do anything. That makes this 7. Which makes this 6. Oh no, this is 0. So now we know that's a 3, 7. That makes this 6. Because right, this has a sum to 10. That's my 6. That's my 7. The 7 is not taken. So that's 8. That's 4. 1, 8. Now we're going. We said here this couldn't be a 1 before, correct? Because 1, even if I paired it with 7 now, it would be 8. 1, 8 is 9. It's too close to 6. So that's my 1. That is a 6 with something big. I mean, 4, 5, or 7. Not 7, I guess. And not 5. 4. 5, 7. That's a 5, 9. That's 4. That is green. What I have left here is 7, which is here. 3 is now not here, so it's here. I think we're going to do this. I honestly felt hopeless first. Not hopeless, but I felt like there was a real possibility that after, an hour of puzzle time, I would just have to give up because I couldn't find where to go next. Those aren't 4. So what am I missing? 4, 9, 8. 4 is not here anymore. So there's definitely a 4 here with 8 or 9. There's definitely a 0 here. There's no 8 here. Oops. So that is not an 8 or a 7. So that's a 6. There's no 6 here. There's no 7 here. This is a 6, 9, 9, 6. So that's 9, 6. Now this is a 4, 9, and that's it. These are not 9. So that's 0, 8, 0, 9. I'm pretty sure this is an incredible puzzle. It never relented. Every single reveal was so purposeful. Let me just check to make sure I'm right. Yeah, this is I can. GDC told me that you were the king of liar puzzles, and I think that is a true statement after this. So well done. Thank you so much for setting this puzzle. Thank you for watching, and I'll see you again on. I don't know. I don't know when I'm going to post this video. So, but I'll see you. I'll see you when I see you. Thanks.